So today we are going to learn about the ROC. I told you that very first we left the video that is with respect to the introduction of set transform. So the second concept was that is the derivation of set transform, right? And the third concept I told you that I'd be leaving the video with respect to what, that is the ROC and the properties of ROC. So we learnt about ROC in the derivation video only. That is, in the derivation video we saw about the ROC. So what is ROC? So the ROC is defined as the, so that is the range of R at which the condition satisfies. So what is the condition? So the condition, this is small r, I'm really sorry, yes and yes. So this is a range of R at which the condition is satisfied. So what is the condition? So the condition is equal to what? That is summation of, that is n is equal to minus infinity to infinity, that is modulus of x of n into, that is your r to the power of minus n, that is lesser than infinity. So for the range of r for which this condition has to be satisfied, so therefore you can say that it is my ROC, right? Yes, this is what is my ROC. And now coming on to the properties of ROC. So my very first property, let me take another one. Yes, so my very first property number 1 of ROC, that states that your ROC, that is consist of ROC of what I can say, the z of, I'm sorry, it is x of z, ROC of x of z, ROC of, that is x of z, it contains what? It contains a ring in the z plane centered about origin. So it contains a ring in the z plane so it contains what? It contains a ring in the z plane, that is what I can say, ring in the z plane centered about the origin, right? So we'll write that. So yes. Yes, so you got it right. So ROC of x of z, that contains the ring in the z plane that is centered at origin. So therefore let me draw how does that look like, right? So I take some time to write and explain. So please don't please don't feel bad. So it's like I take some time to write. So there will be no voice in my video for that particular point of time. So let me draw that. So how does it look like is, this is my, what I can say, the z axis, and I can say that this is the real part, that is what I can say, the RE. So the real part is said to be RE. Yes, RE of, that is what I can say, the, it is the RE of z. Yes, right. And this is what? Imaginary of z, that is IMG of z, right? This is imaginary of z. So this is what is the given. So inside this there is a circle, right? You need to draw a circle. So that is what he is telling, that your ROC is consisting of a circle, that is which is inside the so consists of a circle, or I can say ring in the z plane, that is centered about the origin. So this circle is centered about the origin. So this is what is your first point, right? You got it right? Yes. So now coming on to the second one. So my second one states that ROC does not contain any poles. So my ROC does not contain any poles. So what is any poles? So it is like, your pole is like, what I can say here, that is your x of z is equal to infinity. So for a pole to occur, so your x of z should be is equal to infinity. So therefore as your x of z is a finite, so you can say that ROC, that doesn't contain any poles, right? Yes. So see, I'll write it and show you. So ROC does not contain any poles. That is your x of z that is equal to infinity for your poles to occur. But what is that going to happen as if x of z is a finite value, so I can say that your ROC does not contain any poles, right? I guess you got it. So now coming on to the third point. So the third point is if your x of z is an infinite, so if your x of z is your finite sequence, so if x of z is a finite sequence, so what is that? It's a sequence of finite duration, I can also say. So it is a what I can say. So it is a what I can say. I'll write it finite duration over here. Just a second. I'll rewrite it again. So it is x of n. I'm sorry. It is not x of z. So x of n we are considering and we are telling that it is of finite, that is duration. So what I can say here, ROC is the complete set plane, right? Only just understand these things, don't go to all other things, just understand that if your x of n is a finite sequence, so therefore your ROC is the complete set plane, right? That is what you need to know, right? Yes, so it is duration. So finite duration, so your ROC is what? That is a complete set plane, right? Your ROC is the complete set plane. So complete set plane in the sense what? It will look like this, right? Just a second. Yes, it will look like this. Yes. So this is what is your ROC, right? I guess you got it. So this ROC is complete Z plane. So that is only for your x of n is for finite duration, right? Yes. So now coming on to if your x of n is a right sided sequence. So if your x of n is right sided sequence, so therefore if your x of n is a right sided sequence, so if your x of n is right-sided sequence, here ROC, that is region of convergence, is what? A region of convergence is what I can say, that is outside the circle. So outside the circle in the sense, whatever the circle you draw, you are going to keep it, you are going to draw the region of convergence outside that particular circle. This is real and this is IMG, right? Yes. So this is what is real offset and this is what is imaginary offset and this is what is for a right sided sequence. That is what for a right sided sequence you can see that. So this is your that is your ROC is outside the circle. So this ROC I have shaded outside the circle, so you can see. So this is what is the particular. So now if I consider that my x of n is a left sided sequence, so if an x of n is left sided sequence now, so what is that going to happen? So what is that going to happen is, so that is you get it like this. So here what I can say, the this one ROC is inside the circle, right? ROC is inside the circle. This is really offset and this is imaginary offset. So therefore this is what is the required, right? Yes. So this is what is for here x of n is a left sided sequence. So here ROC is inside the circle, right? Yes. So now coming on to if your x of n is a what I can say, the this one, what is that? It is a two-sided sequence. So if x of n is two-sided sequence, for that is both left and right side, right? What is two side? Two side is both, that is left and right side, right? So if we take a r of n as two-sided sequence, so therefore two-sided sequence, so then what is that going to happen is, so your r of that is your ROC is a concentric ring in the z plane. That is concentric ring in the sense you are going to shade it over here and there would be another concentric ring that you have to write, that is inside this particular ring and that is really smaller than this bigger ring. So first how we have to construct, so you have to construct like this. So I'll show the construction. So the construction is like this. So what is that construction is? So see here, first draw this particular z plane, then draw the circle and after this big circle you are going to write then one smaller circle and then you are going to shade it for bigger circle. So this is what is my required that is for x of the required for ROC for x of n is two-sided sequence, right? So you need to shade it for the bigger circle, no shading for smaller circle. And I told that your ROC is a, that is what I can say, concentric ring in the z plane. So this is what is my concentric ring, this part is my concentric ring, right? So that is what is the property. And the last property is, if your x of n is rational, that is if your z transform x of n is rational, z transform x of z, that is of x of n is rational, so therefore rational, so therefore I can say that, so therefore then ROC contains poles, so then ROC is bounded by poles. So when is your ROC bounded by poles? Your ROC is bounded by poles only when your x of z of, that is x of n, that is z transform x of z of x of n is what I can say, the rational. So therefore you can say that your ROC is bounded by poles or they extend to infinity. And this is what is the properties of ROC. The very first property says that your ROC of z x of z, that is consisting of a ring in a z plane, that is center at origin. And the second one, what is that, is your ROC doesn't contain poles itself. And the third one, if your x of n is a finite if your x of n is a finite sequence, so therefore what is the finite duration, so what is that going to happen is, you can see that your ROC is a complete z plane. So complete z plane in the sense is what? So your complete z plane is like this. So your complete z plane is like this. So you have to shade the complete z plane over here. And for the second one, if the ROC is a left-sided sequence, so your x of n is a left-sided sequence, your ROC is outside the circle. So that is, I am going to shade it outside the circle. So see like this. And then next, if your ROC is a right-sided sequence, so your I'm sorry, your x of n is a right-sided sequence. So therefore your ROC is what I can say, it is the ROC is shaded inside the circle. So this is inside the circle. And next, what is that going to happen is, if your x of n is two-sided sequence, so for two-sided sequence, what's that going to happen? Your ROC is a concentric circle. So that is, first whatever you're writing a circle, so this ROC, along with that you're going to write a concentric circle, and you're going to shade this particular bigger circle, right? This is what is my condition for x of n, that is a two-sided sequence, that is a right-sided and left-sided sequence. So for that, this is the resultant, right? And now if you consider that your x of z of, that is x of n, is rational, so therefore here what I can say, your ROC is bounded by poles, or it will extend to infinity. So this is what is for the ROC, what I can say, the properties. And in the case of tomorrow's class, we'll just start with the problems with respect to Z transform and the properties also. And thank you so much.